Write a general formula to describe each variation. Use the information given to find the constant of proportionality. In part A, we're given that Q is directly proportional to both the cube root of t and the square of d, and Q is equal to 18 when t is equal to 8 and d equals 3. What the author is really trying to say is that Q is directly proportional to the product of the cube root of t and the square of d. So what we need to do is to recall what it means for two quantities to be proportional to one another. What it means is that if we take one quantity and we divide it by the second quantity, then that ratio is always constant. So if one quantity, Q1, is directly proportional to another quantity, Q2, then the ratio of those two quantities, Q1 divided by Q2, will be equal to the constant of proportionality, which I've denoted with the letter K. So our first quantity is Q, and our second quantity is the product of the cube root of t and the square of d. So that gives us Q divided by the product of the cube root of t and the square of d is equal to K. Now we want to write a general formula to describe this variation. So we want to solve for one variable in terms of the other. So in order to solve for Q, we'll simply multiply both sides by the product of the cube root of t and the square of d. That gives us Q is equal to K times the cube root of t times d squared. To find the constant of proportionality, we'll use the constant of proportionality formula and substitute 18 for Q, 8 for t, and 3 for d. We get 18 over the cube root of 8 times the square of 3. The cube root of 8 is 2. The square of 3 is 9. 2 times 9 is 18, and 18 goes into 18 one time. So the constant of proportionality is 1. For part B, we're given that A is directly proportional to the product of h and the square of the radius r. And A is equal to 100 pi when r is equal to 5 and h is equal to 2. So in this case, our first quantity is A, and our second quantity is the product of h and the square of the radius. So we'll end up with A divided by the product of h and the square of r is equal to K. To write a formula for A, we'll multiply both sides by hr squared, and that gives us A is equal to K times h times r squared. To find the constant of proportionality, we'll substitute 100 pi for A, 5 for r, and 2 for h. We get 100 pi divided by the product of 2 and the square of 5. Well, the square of 5 is 25, and 25 times 2 is 50. 50 divides into 100 2 times, so our constant of proportionality is 2 pi. In part C, we're given that V is directly proportional to the product of B and H. And V is equal to 192 when B is equal to 48 and H is equal to 4. So using a similar approach to parts A and B, we get V divided by the product of B and H is equal to a constant K. We multiply both sides by BH, and that gives us V is equal to KBH. To find the constant of proportionality, we substitute the given values for V, B, and H into the constant of proportionality formula. We get 192 divided by the product of 48 and 4. 4 goes into 192 48 times, and 48 divided by 48 is 1, so the constant of proportionality is 1. Finally, in part D, we're given that t is directly proportional to the product of the square root of p and the square of u, and t is equal to 18 when p is equal to 4 and u is equal to 6. So we use the same strategy that we've used all along. We get t divided by the product of the square root of p and the square of u is equal to the constant of proportionality, k. In order to solve for t, we multiply both sides by the square root of p times the square of u. We get t is equal to k times the square root of p times the square of u. To find the constant of proportionality, we substitute the given values for t, p, and u into the constant of proportionality formula. We get 18 divided by the square root of 4 times the square of 6. The square of 6 is 36, and 18 goes into 36 2 times. The square root of 4 is 2, and 2 times 2 is 4, so this reduces to 1 over 4. So the constant of proportionality is 1/4, or if you like, you could write it as a decimal, 0.25.